enduring Martian conundrum is resolved in a second publication that was published in Science. A rock formation rich in olivine was previously found by Mars orbiters. This structure is over 27,000 square miles, 70,000 square kilometers in size, or almost the size of South Carolina, and extends from the interior margin of Jezero crater into the surrounding area. Scientists have proposed a number of explanations for the prevalence of olivine over such a large area of the surface, including meteorite strikes, volcanic eruptions, and sedimentary processes. Another theory states that the olivine formed deep underground from molten rock that was gradually cooling and was eventually revealed by erosion. Yang Liu and her co-authors from NASA's Jet Propulsion Laboratory in Southern California believe that the final response is the most likely one. After repeatedly abrading a rock to expose its composition, the scientists concentrated on the enormous grain size of the olivine as well as the rock's chemistry and texture. Using Perseverance's planetary instrument for X-ray lithochemistry, or PIXL, they observed the olivine grains in the region measure 1 to 3 millimeters, which is substantially larger than would be predicted for olivine that formed in quickly cooling lava close to the planet's surface. According to Liu, a very slow cooling environment is required because of the large crystal size and homogeneous composition in the specific rock texture. Jezero's magma was therefore most likely not bursting on the surface. Modern science instruments. The findings of the scientific instruments that help determine that the crater bottom is covered with igneous rocks are discussed in the two Science Advances papers. The instruments are the ground-penetrating radar RIMFAX, radar imager for Mars subsurface experiment, and the Perseverance SuperCam laser. The rock vaporizing laser on SuperCam can zap a target as small as a pencil tip from a distance of up to 20 feet, 7 meters. The resulting vapor is examined using a visible light spectrometer to ascertain the chemical composition of the rock. SuperCam zapped 1,450 spots over the course of Perseverance's first 10 months on Mars, helping scientists come to the conclusion that there are igneous rocks on the crater floor. SuperCam also used near-infrared light to determine that water had an impact on the minerals in the crater floor rocks. It is the first sensor of that kind on Mars. The combined laser and infrared measurements, however, revealed that the changes were not pervasive throughout the crater floor. A flurry of spacecraft neared Mars in late 2003 and early 2004 with different degrees of success. Nozomi, a spacecraft launched by Japan in 1998 and traveling at a sedate rate, was the first to approach the planet's vicinity. Unfortunately, issues made it impossible to launch it into Mars orbit. In the middle of 2003, the European Space Agency's Mars Express mission departed for the Red Planet. With instruments to study the atmosphere, surface, and subsurface, it entered Mars orbit on December 25th. However, the British lander Beagle 2, which was meant to search for signs of past or present life in the rocks and soil, was unable to establish radio contact after touching down on the Martian surface the same day. Exactly a few weeks after landing, the Mars Express orbiter found huge fields of water ice and carbon dioxide ice at the southern pole, establishing that the southern summer residual cap contains permanently frozen water just like the northern one. It also revealed substantial sulfur-rich deposits, particularly in the Valles Marineris, and clay minerals in the heavily cratered terrains. Scientists expected to find sedimentary rock, which would have formed as sand and mud settled in a formerly watery environment because the crater had once contained a lake billions of years ago when NASA's Perseverance Mars rover began analyzing rocks on the floor of Jezero crater in the spring of 2021. Instead, they discovered that the floor was made up of two different kinds of igneous rock, one of which was produced by volcanic activity on the surface and the other by the production of magma beneath the surface. For new publications that were published on August 25th provide details on the discoveries. In a second study published in the same journal, Science, peculiar rocks that seem to have formed from a substantial bulk of lava are described. An outline of Perseverance's exploration of the crater bottom from April 2022 until it arrived at the ancient river delta of Jezero is given in one research in the journal. The other two publications go into detail on how Perseverance's ground-penetrating radar and rock-vaporizing laser proved that igneous materials covered the crater floor. Science Advances is where both papers were released. By maintaining information about the specific moment of development, crystals found in igneous rocks act as reliable timekeepers. The igneous rocks we discovered are really significant because they can tell us when the lake in Jezero existed. We know it was there more recently than the igneous crater floor materials produced, says Ken Farley of Caltech, the project scientist for Perseverance and the lead author of the first of the two science investigations. This will provide answers to some crucial questions, like when Mars' temperature changed to become as frigid and dry as it is today, and when the planet's surface could support lakes and rivers. However, due to the way igneous rock forms, it is not the greatest material to preserve any potential remnants of microscopic life from the prehistoric era. Contrarily, dating sedimentary rock can be challenging, particularly if it contains rock fragments that were formed at various times before the rock sediment was deposited. Sedimentary rock, on the other hand, usually forms in moist environments that are conducive to life and is better at maintaining prehistoric life traces. That is why the sediment-rich river delta that Perseverance has been exploring since April 2022 has captured the attention of scientists. The rover has begun drilling and collecting core samples of sedimentary rocks in order to potentially transport them to Earth for analysis by powerful lab equipment that is too large to fly to Mars. The first spacecraft to orbit Mars, Mariner 9, did so in November 1971 and continued to do so until October 1972. The results included a wide variety of spectroscopic, radio propagation, and photographic information. A history of widespread volcanism, ancient water erosion, and significant surface change by internal processes were shown in over 7,330 pictures, or 80% of the surface. The Viking voyage's primary goal was the search for alien life. There was no definitive proof of biological activity found, but the extensive equipment on the two orbiters and the two landers provided thorough data on Martian geology, meteorology, and the physics and chemistry of the upper atmosphere. Vikings 1 and 2 were introduced in June and August of 1976, respectively. The orbiters released the lander modules once they had located appropriate landing sites. Viking 1 landed on Christ Planitia, 22 degrees north, 48 degrees west, on July 20, 1976, while Viking 2 landed on Utopia Planitia, 48 degrees north, 226 degrees west, which was 6,500 kilometers, 4,000 miles, away, on September 3, 1976. In 1988, Soviet scientists launched the Phobos 1 and 2 spacecraft to orbit Mars and study its two satellites through leisurely flybys. Phobos 1 was lost for the entire year-long mission, while Phobos 2 made it to Mars at the start of 1989 and sent back data on the planet and Phobos for several days before malfunctioning. In the 1990s, many American spacecraft missions to Mars were unsuccessful, but on July 4, 1997, Mars Pathfinder made a successful landing in Christ Planitia, 19 degrees north, 33 degrees west, and deployed the robotic wheeled rover Sojourner. The next mission was the Mars Global Surveyor, which touched down on Mars in September 1997 and started mapping the planet's various features from orbit in March 1999. These included Martian geography, minerals, and gravitational and magnetic fields. The spacecraft also had cameras that could take photographs of the surface in wide angle and detail with a resolution of 1.5 meters, 5 feet. Mars Odyssey successfully orbited the planet in October 2001 and started mapping more features, such as the chemical composition of the surface, the presence of near-surface ice, and the physical characteristics of surrounding objects. Neutron observations suggest that there may be massive subsurface reservoirs of water ice in the polar regions above latitude 60 degrees. Mars Odyssey also discovered tunnels on a volcano by revealing that the temperatures of the cave entrances, which looked as black circular markings, did not change as much as the surrounding surface. That was for today. Thank you for staying with us. Don't forget to like our video and subscribe to our channel.